This is my 8th video lesson for the Ionic Bond unit. In this lesson, we'll be learning how to name ionic compounds containing a polyvalent metal. So go to page 26 in the class packet. So using your knowledge from the previous lesson, name the following compounds. Here we have FeBr3 and FeBr2. What do you notice about the names? Can they be the same? And why or why not? So here's a picture of each of these substances. Notice that they're different. One of them is black, the other one is reddish orange. So based off the rules from the previous lesson, they will have the same name. So we need an additional rule to make a distinction between these two compounds. Learning target. At the end of the lesson, I'll be able to name ionic compounds with polyvalent metals. For announcements, there will be homework number 8 based off this lesson. There will be a quiz junior pod based off PowerPoint 7 and PowerPoint 8. And there will be an exam number 4 based off the Ionic Bond unit. Polyvalent metals are transition metals that can have multiple charges or oxidation states. So transition metals are located in the middle of the periodic table. Here's an example. This is iron. On the periodic table, on your reference table, this is the oxidation state or the charges. So if we notice, these metals have multiple charges or oxidation state. So iron can either be +2 or +3. Check of understanding number 1. Are all transition metals polyvalent? If you look at the periodic table, the answer is no. One unique property of polyvalent metals is that when they're aqueous, when they dissolve in solution, they have a different color. For example, chromium, when it's +2, it is blue. When it's +3, it is green. When it's +6, it is orange. Here's a table listing out the colors for each metal ion. Now I'm going to highlight the polyvalent metals on the periodic table. Take a moment to highlight them in your packet. Notice that some of the transition metals are not polyvalent. Learning check number 1. Which aqueous salt solution has a color? Pause the video and resume once you have the answer. So in order for the salt solution to have a color, it needs to have a polyvalent metal. So if we look at these metals, barium, copper, strontium, and magnesium, only copper is a transition metal that is polyvalent. Learning check number 2. An aqueous solution of potassium chromate is colored because a transition metal is present. Pause the video and resume once you complete this. This is a SAT2 question. Potassium is K. K is not a transition metal. Chromate is a polyatomic ion, is Cr(O4). So you have to memorize the polyatomic ions for the SAT2. Cr is a polyvalent transition metal. So as a result, potassium chromate is colored. So the best answer is choice C. Both statement 1 and 2 are true, and statement 2 is the correct explanation of statement 1. Now we are going to go over the rules of naming ionic compounds with polyvalent metal. As we discussed in the motivation, we need an additional rule. So the additional rule is using Roman numerals to indicate the charge of the metal. So this was the rule you learned last time. We're now going to add the Roman numeral. So the Roman numeral is in parentheses and it goes after the metal. So the rules of polyatomic ions will stay the same. Check of understanding number 2. What's the names of these substances from the motivation? Let's look at the first one. If we crisscross backwards, this iron is going to have a charge of +2. So when we write the name, we're going to put the Roman numeral 2 in parentheses. So the name is iron 2 bromide. For this one, if we crisscross backwards, this iron is going to have a charge of +3. So the name of the substance is iron 3 bromide. Check of understanding number 3. A student named ZNO as zinc 2 oxide. Is this student correct? The answer is no. Why? Because zinc is not polyvalent. Even though zinc is a transition metal, it does not have multiple charges. So you do not need the Roman numeral. You do not put it. So ZNO is just zinc oxide. Learning check number 3. What is the IUPAC name for CuCl2? Pause the video and resume once you get the answer. IUPAC just stands for the chemical name. So in order to figure out the name of this, we have to crisscross backwards. If we do that, we get copper having a charge of +2. Since copper is a polyvalent metal, you need to put the Roman numeral. So the answer is choice 3. Learning trick number 4. What is the IUPAC name for AgCl? Pause the video and resume once you complete this. So if we crisscross backwards, Ag will have a charge of +1. If you look at the periodic table, Ag, which is silver, is not a polyvalent metal. So you do not need the Roman numerals, so the answer is choice 1. Learning trick number 5. The correct formula for nickel 2 hydroxide is what? Pause the video and resume once you complete this. So we know nickel has a charge of +2 because of the Roman numeral. If we look at table E on the reference table, you get hydroxide is OH with a charge of -1. Now we crisscross the charges, you get nickel, and since the subscript is greater than 1, you gotta put parentheses for the OH. And now 1 is invisible, so we get nickel, parentheses, hydroxide 2. So this is nickel 2 hydroxide, so the answer is choice 4. Now we're going to talk about a special case, Mercury 1. In solution, Hg+1 exists as a polyatomic ion, Hg2, with a charge of +2. Why does that happen? Because Hg+1 is unstable. Therefore, it will bond with another Hg+1 to form Hg2 +2. This information is found on table E in your reference table. So notice that Hg2 +2 is listed as Mercury 1. Do not reduce the subscript 2 in Hg2 is the same reason as peroxide. For example, you have Hg2, Br2. You do not reduce the subscript because Hg2 is a polyatomic ion. It's treated as one unit. On the regions, questions about Mercury 1 are quite rare. So there's other formats in naming polyvalent ionic compounds. They basically modify the ending of the Latin name counterpart. For example, iron, the Latin name is ferrum, so that's where we get Fe for iron. So iron can have a charge of +3 and +2. So you modify the suffixes based off the charge. If the charge is greater, then it's ic. If it's less, then it's os. So for charge of +3, it'll be ferric oxide. If its charge is +2, it'll be ferrous oxide. So this format is not on the regions. I'm just letting you know it exists if you're planning to read the textbook or other science literature. For part 1 in the practice, I want you to write the chemical formula given the chemical name. Try to do it yourself. Pause the video. Resume is completed. Here are the answers. Check of understanding. A student named the following formula as A2O3 as aluminum-free oxide. Explain why the student is incorrect. So if we look at the periodic table, aluminum does not have multiple charges. It is not a polyvalent metal. So you do not put a Roman numeral 3 here. So this is just aluminum oxide. For part 2 practice, I want you to write the chemical name given the chemical formula. Pause the video and resume once you've done this. Okay, so here's the answers. For part 3 is a mixed set, so I want you to write the chemical name given ionic compounds. Pause the video and resume once you complete this. So here's the answers. So notice some of the names do not have Roman numerals because they're not polyvalent metals. So keep that in mind. Don't put Roman numerals if it's not required, but put Roman numerals if it is. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz. There will be an exam on Unit 5A on the ionic bond. Our next unit will be Unit 5B on the covalent bond.